the quadratic family of functions. The parent for the quadratic family of functions is y equals x squared. So after you select a point on the x-axis, you square it to get the right point on the y-axis. For instance, if x equals 1, y would equal 1, because 1 squared is 1. And if x equaled negative 2, y would equal 4, because, if you recall, any negative number squared is also going to be a positive number, and 2 times 2 is 4. Alright, this shape that this creates, it's sort of U-shaped, but it's not really because the sides don't go straight up. This is a parabola, and a parabola is just the shape of the graph of a quadratic function. It will either point up like a U-shape or sort of down like a rainbow, but it will never point left or right. Now let's think about the domain and the range. Can you think of any number that you couldn't square? I can square positive numbers, and I can square negative numbers, and I can even square 0. So the domain for this family of functions is all real numbers. Now let's think about the range. Whenever I square positive numbers, I get bigger positive numbers, and whenever I square negative numbers, I also get positive numbers. So there's nothing in this family that's going to give me a negative number, so the range for the parent is just everything greater than 0, or y is greater than 0. Now, the range is naturally all positive numbers, but of course, if the function were shifted down, this would cause, some of the range values to be negative. So in this case, for the second parabola I've drawn, the domain is all real numbers, but the range is just that y is, greater than the lowest point on the graph. So the range in this case is y is greater than or equal to negative 2. So the range is going to be affected by where either the minimum of the graph is or where the maximum of the graph is. Let's talk a little more about the anatomy of quadratic functions. An imaginary line that cuts the center of a parabola is called the axis of symmetry because it cuts the parabola into two equal halves. This point, right where the axis of symmetry touches the parabola, is called the vertex. And of course, the shape of this function is called the parabola. Now, if the parabola points up, if we have a second-degree polynomial with a positive leading coefficient, then the vertex is going to be the lowest point, or a minimum. However, if we had a negative out in front of our quadratic, if we had a negative leading coefficient, then the graph would point down, and that vertex instead would be a maximum.